A DXF or IFC file provided by an architect isn't necessarily going to be in the right coordinate system. In this case here, we have an IFC file with a 0, 0 origin. If we zoom extents, you can see how far away that file is from our local site. In this case, I want to position the building 6 meters, offset this boundary line. And I know the corner of the building is also going to be 9 meters off this line. I'm now going to use the Snap To toolbar to find the intersection point of these two lines. I know the elevation of my floor slab, so I'm going to key that in as the elevation of the intersection point. I'm also going to use the Snap To toolbar to create a point at the end of this line to orient the building. Now I'm going to turn off these two files to reduce clutter and turn on my IFC file. Trimble Access will detect that your IFC file is a long way from your job data and prompt you to georeference. If I click yes, it will shift the IFC file to the centroid or center of your job data. This reduces the amount of panning needed to select points in your IFC file and your job data. Now I need to pick a point on my map file. So here I need to make sure I pick the point on the top of the floor slab, because that was the elevation I keyed in when I created my intersection point. Then I'm going to pick the matching point in my job. I will continue to do the same thing with the second point. In this case, I've picked point A in the map file, then point A in the job data, then repeated with points B. In some cases, it may be easier to pick both point A and B on the map file, then pick point A and B in the job data. In the map, you can now see how the IFC file is going to get matched to the points in the job. Clicking Accept will apply that georeferencing to your map file. So I'm going to turn on these other map files for context, and you can see there's been a scale applied to this building and it doesn't fit within the building parcel. So I will return back to the georeferencing form. I'll go into options and I'll set the horizontal scaling to 1 because I don't want this file to be scaled. I will also untick the fixed horizontal rotation to 0 because I want to rotate this building to align with the boundary. In our example, point A has the elevation of the building slab, so we want to make sure the translate elevation method is set to point A. Now when I click Calc, we can see that building has shifted and it's now inside the parcel. We can scroll down in the georeference form and see the translations and rotations that have been applied to that map file. The process of georeferencing a map file creates a world file, which is stored alongside your map file in your project folder. It doesn't change the IFC file, so if you would like to share the georeferencing, you should share both the map file and the world file. Another way of accessing the georeference command is through the menu structure. Through Kogo, Adjust, Georeference. However, this will not shift your map file to the centroid of your project and may result in excessive panning between your map file and your job data. Often these workflows are done in the office, but in some situations, such as positioning map files off surveyed boundaries, you can save yourself a trip back to the office by positioning them in the field.